So I guess I'm going to start with a question, right? How many of you are actually attempting to pull data out of PDFs like now, or any sort of like sucky format?
I tried recently, it was a disaster.
It was a disaster? Yeah, so you too, right? I mean, so it's like, this is something that we run into a lot, especially in an institution where there's a lot of data stored over time. And a couple of examples that came to mind while I was trying to figure out why I even started doing some of this work when I worked at the FDA was we just had a lot of people that needed a format in which they could store data quickly and easily, and they chose PDFs because it's an easy format to get things into that it doesn't require any specific tool or editor to see, and realistically any PDF viewer will open a PDF and maintain its formatting, right? Like that's kind of the nice thing about PDFs. So at the FDA and other places that I worked, academic institutions and elsewhere, there's a lot of legacy data that's just trapped up in PDF format, and sometimes it's not legacy data, it's data that's coming in live that's trapped up in PDF. So a lot of these tools that I'll walk through are actual tools that I had to use to generate data sets, like some that Ricky had to deal with when I was... he worked on an R project that I headed for a little while. We gave them like some 8,000 sheets of data that were actually extracted from PDFs. These were tables that we've had to pull out and hand over. And initially, the people that were trying to do this work were manually transcribing these tables. If they could copy them, they were copying them over with errors. It was kind of amazing. At one point, I calculated their error rate at like 1 in 7, and it was just fabulous. Because as they got more tired, they started putting decimal places in wrong places, so you suddenly had an entity that was 130%, and nobody really checked, right? So we'll talk about, extracting tables. Some of the things that we'll talk about here are, I did another piece of math after a late night of frustrated coding to extract PDFs, where we were able to take data out of PDF format that was part of an active data set, move it out, and again, transfer it over into, in this case, I had to hand them over in CSVs because the system that ingested the data could only take... Oh, it wasn't even CSVs, sorry. It was a macro-enabled Excel sheet. So I extracted CSVs and then smushed macro back into it and then had to hand them over. But I did the math on that thing, and the data had come in as PDFs because of an error in what was requested, in which somebody had accidentally said all data must be submitted as a PDF. So a lot of things that were brought in were either Word documents that were converted to PDF, sure, whatever, that's fine, but CSVs that had been then converted to PDFs and then sent back in that then I had to un-PDF, which meant that there was a lot of lost data because of column length and all that fun stuff. So all of that to say is a lot of these tools and a lot of these libraries and packages that you'll see, and I made this Jupyter notebook available to Ricky over there, so he can share it with you guys. It's all just easy to use. It should be a good place to start. But a lot of these functions are functions that I used on a day-to-day in order to take data out of an unusable readable digital format, so that I could put it into a database so that we could use it long-term. And if it wasn't going into a database, I started storing them as at least CSVs, if not another easy-to-use, ingestible file type, JSON, whatever, that I knew could at least had some legacy legs to it so that something could ingest it. So again, it's not the fault of any one individual or any institution that all this data is locked up in PDFs or locked up in unusable ways. It's just that it was the most convenient storage type. And to the person in the corner there that asked about Tesseract, right? One of the other things that I encountered and had to deal with, and again, when we get to the later parts of this, we'll talk about why the module is built the way that it is we had a lot of legal documents that were submitted as briefs that people had handed over that then were scanned by an individual and stored as a PDF. So there is no there are no bytes associated with that. You have to OCR that out the best that you can. And it was crazy. I was talking to somebody and they were I was like, how do you find a file when you can't search for the file? And they had nondescript titles to them. It was impossible. And they were like, well, this is a lawyer. They're like, well, there's this one lawyer who's been here for 20 years who was here for long enough that if we need a precedent document, we just ask him and he tells us. So there was like, there was no like plan. The guy was ready to retire. There was no plan. So we had to come up with a strategy to try and pull some of the data out, and this was something that I was like working on, and luckily was able to hand off to somebody after I was like, here's some garbage code that does what you need, go make it better. Like I got you started, like roll along. So you'll get legacy items that are stored as PDFs because they're just scans, and those scans are PDFs, like they just come out as PDFs. So this is my basic flow, and it's very basic, and these are the checks you should do. Is it machine readable? And the way that you can easily check if it's machine readable is just open the PDF and see if you can highlight it. If you can highlight it, there's byte structure there, you'll be able to pull it out. Cool, that is like the best case scenario. If no, you're gonna have to go do something and OCR it out. That's the only way to realistically get that data out, and that comes with its own formatting junk, and we'll see some of it, yeah.
Do you know if Adobe automatically attempts to OCR?
Yeah. And if you have access to Adobe Pro, the Adobe API is open, and so you can actually hit it with like some system packages in Python and use Adobe's OCR function to pull the text out, and it does a pretty good job.
Would you mind saying what OCR is?
Oh yeah, so OCR is optical character recognition. So many people's went out, collected a lot of text and essentially did the painstaking work of tagging. Some of that tagging was done by you all with CAPTCHAs, right? Like this letter is an A, this letter is a B. So they've trained algorithms against those tagged letters. So now it's getting better with handwriting. It has gotten a lot better with handwriting in the last few years. But now it's able to recognize a letter, recognize the shape of that letter, and then say, hey, this letter is the letter A, letter B, C, so on and so forth, and rewrite your strings. It gets things wrong. Sometimes I find that P's and Q's get confused. Lowercase p and lowercase q will get confused depending on the script that's used. But it's better than nothing, and oftentimes I will couple like an OCR engine's output with just like a quick crude means of doing some sort of spell check to be like, hey, instead of the word queen, it's P-U-E-E-N, and I'm like, there's no other word that could be unless it's a language that I'm not aware of, right? So we'll use things like OCR engines to pull all this text out, and so that honestly is it's a likely state that you'll end up in if you're working with legacy documents. And the really cool thing about optical character recognition is people have started training optical character recognition algorithms on everything beyond just like the Roman alphabet. One of the examples that I use OCR for is my dad has a lot of legal documents that belong to his father that he doesn't want to use a commercial OCR engine for, that he wants to use just at home. The Tesseract library that I'll show a quick example of has 48, the last I looked, maybe more, different language character sets. And so what I built for him is something where he can just load up all of his documents into a home server, and it just sort of like sequentially just reads them out the best that it can, and then he just goes and edits. I have it dump out as a docx, and he just goes through and edits his documents for whatever legacy he needs out of it. So if you're looking at documents that have dates past, at least in my experience, it's been like past 1980, chances are you're going to end up with a non-machine readable PDF that somebody scanned in at a later time as like just a scan. Modern scanners have gotten better in that they will try and digitally tag that text as it goes through, so you might end up with a readable PDF. But I always just check. That's the first step to my my math is it machine readable? If the answer is no, then I start thinking about how much is this data really worth to anybody? Do I really need to spend the time to run OCR algorithms across it? Because OCR is energetically unfavorable. It's getting faster, it's getting better with multi-core, use parallelization. You can do it a little bit faster, but it is still energetically unfavorable. The next question that I ask, because I'm a scientist, is I have to ask the question, does it contain tables? A lot of the things that I have to work on that I've had to extract text out of has contained tables, and that comes with its own fun it comes with its own fun, interesting problems. If it doesn't contain tables and it doesn't contain images, I'll just use two libraries that I've become very comfortable with, which are pypdf and pynewpdf, and they've been sort of like dueling it out over the last few years to see who's going to be the more dominant of the two. PyPDF has gotten a real big boost in the last, at least I've noticed in the last year, there's like a new maintainer on the library, and it's been baked into, there's a PyPDF 2, PyPDF and PyPDF 2 have now merged, and it's been baked into a lot of like, crash courses people have put together for how to do like, machine learning or just like, basic AI work on a local machine. We'll often use the PyPDF library right now to bring stuff in, but pynewpdf, which uses something called, which uses a C engine called FITS, is actually pretty powerful, and we'll use it for an interesting use case that in this example. The last thing is, does it contain images? As you guys are aware, images require you to be able to tesseract out, and yeah, okay, my flow does go out to tesseract. If it's an image, if it's a flattened image, there's no way to get that text out other than OCRing, and so you'll end up back at the first bit of no, is it machine readable? Essentially, it's not machine readable, so you'll have to use an optical character recognition engine to bring it out. The reason, again, that I use Tesseract is because Tesseract is free, it's open source, it's a collaboration between Google and a bunch of like academic institutions, and it's pretty powerful and it works really fast, and it incorporates well with my Python flows. So I brought two PDFs here. One, selfishly, is a PDF that I know really well. It's me on the right here. And as I'm sure many of you have seen, a lot of academic publications are multi-columnar PDFs. When I first started doing PDF text extractions, this would be my nightmare. Because many of the original, original engines that were written to do PDF extractions would look at two columns and treat them as one contiguous string across. So I had to start doing really fun stuff like figuring out like how many breaks there are right here, or how many like carriage returns, or how many like new lines there are, and say, okay, if you see X number of new lines, treat that as set 1, X number of new lines, set 2, and so I would just like sort it out and shuffle it back together, which was a very fun experience, and you'll also see why this becomes problematic later if you have tables in these multi-columnar things. Single column is essentially the best kind of digitally readable PDF, because you just treat it as a single column, it just reads left to right, and all of these PDF engines are really good at just picking them up left to right, and they'll just read and create your output. Depending on what you want to do, you can either leave them in with new lines or not new lines. If you're trying to recreate them, you can do that using the new lines as line breaks. Or if you don't, for a lot of the work I did, I actually would strip out all like line breaks, carriage returns, any additional formatting, so I could just treat it as one contiguous string, because I was looking for I was either string searching for text inside the thing, or whatever function that I was trying to write. Having it just be treated as one giant string was actually a lot easier for me. It was pretty fast, unless I needed the breaks to be able to find specific sections. Like in this case, if I'm trying to find the section that's called mortality, knowing that it's broken out differently helps me find stuff.
Question?
Yeah, go ahead.
You mentioned line breaks. The libraries you mentioned, are they pretty good at doing detecting encodings?
No. But they're not bad, but they can break. And I'll actually show an example in a little bit. And actually, when we were working on this together, I ran into an encoding issue, and I just sort of I don't know how I solved it. I think I just ignored it, or just forced a Latin 1 encoding, which I found to be a little bit more universal than UTF-8. It's strange. I don't know. There's just some really, but they can be pretty good, but they run into the same problems in that sometimes they just can't detect special characters. So you'll end up with these weird byte strings that it just doesn't know what they are, and so there's a game you can play to try and figure out what the actual encoding that you want to use. I don't know if anybody else has any experience with this, but for some reason when I do PDF extractions, I find UTF-8 works the least. I'll try UTF-8. If it doesn't work, I'll go to ASCII. If it doesn't work, I'll just push Latin 1 on it, and it'll just do something, which is, again, better than nothing for me.
And then for like latex and anything else for these type of documents, do you have any comments on that?
Well, for
you
most
try?
like characters, you can't really put them into UTF-8.
With carriage returns?
No, like if you have multi-character,
Oh, yeah, again, this is what I mean.
there's no way to force that to UTF.
No, it just doesn't. Yeah, and I think that might be part of the problem is that, and like I said, that's just my hierarchical order going down the different encodings.
You can force 16 bits a day. It's not going to
Yeah,
be pretty.
it's not going to work well. And it's, I mean, and this is honestly like a big takeaway that you should is, what is your use case, and you're going to have to potentially tune whatever you're extracting to your particular use case in order to get your data out. I always approach it from the perspective of any data is better than no data, because I'm usually starting from a place of zero, and I have no access, so I'm trying to get anything I can back out. Yeah, so where were we? Oh, yeah, so single column is usually a little bit easier to work with. And for some of the for some of the things that you might need to do with, like, let's say in the example that you guys had with RAG, I heard you guys, like, somebody came and talked to you guys about RAG with an LLM. The amount of text you need in order to get a meaningful response depends. It's variable depending on what you're actually trying to do. If you're trying to, like, recapture a full document and get, like, full understanding, then it becomes really important that you get all the text out as, like, effectively as possible. But for some of the things that I do, it's like, as long as the fields or the regions of the text that I need are good enough, I'll just ignore any weird errors, or I'll work around the error to get to the text I need. Okay, cool. So the reason that I use these two PDFs is to demonstrate sort of the issues that you can run into when you're working with either single column or multi-column here. So the two that I picked for this particular example are pypdf and pypdf/pypdf2 because of that merge that occurred, I think, in the last year, and then pymupdf, which uses this FITS C engine. Initially, when I started doing this work, FITS was actually better at being able to sort of read weird PDFs, but pymupdf actually ended up being able to extract the data a little bit more efficiently, and as I was reading more about FITS and pymupdf, some of the users were explaining that FITS is actually just a little bit faster but a little bit sloppier, and so if speed matters to you, using FITS and the pymupdf, over FITS pymupdf is a better engine, and actually FITS actually will help us pull images later for some of the work to do the Tesseract stuff. So this is where I was saying that I kind of lied, where I was like, oh, I'll use pypdf the most. But when I was looking back through some of my more recent-ish flows, I was actually using FITS and pymupdf a little bit more because I needed speed mattered, and it was able to get at the data that I particularly needed. And also, I was popping images out. Particularly, I was popping, that's in this example here, I was popping captions out of I was popping captions out of figures so that I could, like, know what was in a particular place. So if we see the single column PDF reader here, and again, this ran real quick. This is the first page. You can see that it pulled the data out pretty fast. It's, again, with fairly reasonable fidelity, and as you can see, there's, like, interesting line breaks where the line breaks are, and these line breaks will actually recapture what you actually see in the particular PDF itself. I think this is page 2. We grabbed page 1, thus the header to this document. If we use FITS to do the same thing, again, visually they look very similar, but what you'll start to notice is that there are some differences in terms of actually being able to see where line breaks are. FITS is a little bit more aggressive when it comes to line breaks than pypdf2, but again, they're both, it comes down to what is your use case and what are you trying to do. If line breaks don't really matter, then you can go ahead and just use either one of these pretty fast to read a document in. I think the largest document that I passed through either one of these was like 280 pages, and it was pretty fast. I'm going to say under like a minute to pull all the text out and spit it back out into like a text file for me to be able to work with later.
When you say more aggressive, you mean Fitz does a better job with the line breaks? Or?
Fitz just seems to inject more line breaks in places, and I haven't been able to figure out why it does that. That's what I mean by more aggressive. So like, this was actually an idea that Ricky gave here, where he was like, hey, why don't you just do a diff lib to see the difference between these two, to see if where the line breaks are. And as you can see here, like Fitz is actually picking up the line breaks differently than pymu-pdf does, and you can see that like, you know, there is no alignment one-to-one. And again, if your end goal is to just get the text out and use it, these might not matter. But if you're looking for particular regions by either like line count, or if you're looking for particular regions by page count, this can become problematic. So to further demonstrate this, I'm just gonna like remove as much of the breaks as I can, and we'll just use NLTK to look at the first five sentences and see what actually happens. And as you can see, if you remove most of the line breaks and then you just sort of treat these as sentence tokens and look at them, you can see that both of these pick up around the same places, and as you can see, Fitz here is adding additional it adds additional line breaks that you're actually removing that, again, in pymu-pdf, you get this weird carriage return here. So now that you have a means to like, you know, pull text out of a single column, I thought it would be interesting for us to see what happens with multi-columnar PDFs. And I hadn't switched between these two libraries all that much once I had one working for multi-columnar. And I used pypdf mostly to do multi-columnar reads, because when I first started using Fitz and pymu-pdf, it was really bad at doing multi-columns. It wouldn't read the column, it would read across. And so I actually ended up switching from Fitz to pypdf and never looking back for a long time until somebody told me I needed to go back and check on Fitz, because there were some additional updates, and pypdf 2 hadn't been updated in like 5 years or something at that point. So if we look at a multi-column, if we look at the multi-column text the PDF up above, you actually see that this actually reads across the columns and is actually able to reconstruct the strings in a reasonable way where you can actually read them across. So it's actually reading down the column, switches to the second column, and goes. And this is, again, a best case scenario. Same thing with Fitz. Again, in the beginning, it was really bad at reading multi-column, but now you can see that it's actually like, you know, reading across just the same as you would expect from the pypdf 2. And okay, so the next thing here is, you know, does speed of extraction matter? And this is, I was reading in the documentation and some of the stack chats to try and figure out why you would pick one over the other. And the big reason that people, again, recommended pymu-pdf and Fitz over the other is speed. If you're looking for speed over a large document repository that has big documents, use Fitz and pymu-pdf. And again, with the updates that have been made over the last, you know, I guess 5 years to both pypdf and pymu-pdf, you're able to get the text out pretty reasonably fast. And again, if you have unlimited time, or time is not necessarily a factor, I prefer pypdf because, one, I'm just more comfortable with it, and it seems to, again, be a little bit better when it comes to the number of new line breaks and carriage returns that it injects. So, table extraction. The two examples that I use here are PDF Plumber and Tabula. And I was describing this as why I would pick one over the other. I prefer Tabula significantly to the PDF Plumber. The reason that I would use PDF Plumber is PDF Plumber requires a little bit less setup beyond just sort of pip installing PDF Plumber. Tabula requires you to have a functional Java runtime environment in order to be able to function. One of the reasons that this can become a problem is we have some remote servers that we had some remote Linux environments that I didn't have access to install things on, and they didn't have a JRE, and so I had access to Python and a bunch of Python libraries through a Nexus repo, but I didn't have Java, and anytime I asked for an install, they would yell at me and ask me why I was trying to install Oracle Java, and I was like, no, I just want this one. It's free. Nobody cares. But Tabula is really good at reading an entire document's tables, and it actually essentially creates it treats tables like an HTML table, and it just looks for the table header breaks, and it just sort of creates like with this particular little script, what it does is it actually goes through and will create a series of tables associated with each table inside the PDF, and then you can, in this case, I just concatenated them all together into one giant PDF.
So, Raju, if I could interrupt you.
Yeah, go ahead.
So, then, what I'm inferring from what you just said, if you are reading a document and say you come on a page where there's like 10 tables, right, in, say, dashboard form or something, that's not an issue, or is that...
That's actually a really good question, and I have not tried that. But I wonder what Tabula would do with it. I would assume that it should be able to handle it, but that's a really good question. And that is something that you will run into a lot in scientific literature. It just happens to be that many of the papers and things that I worked on just had one table per page kind of thing. And it actually does really good jobs with rotated tables as well. So like if it's a landscape versus...
Right.
Good.
What about the tables like tax forms where you have the boxes, but there'll be a descriptor at the bottom of the box, but the actual information is inside the box?
Yeah. It'll if it behaves like any of the other tables that I've seen that are like that, it'll treat them as two separate rows. So you'll end up with like a row of data, and then you'll end up with like a gapped row of like descriptors, and then a row of data, and then a gapped row of descriptors. And if it's like structured where it's like you have two table sets next to one another, it might treat them as individual cells. One of the there was a table that there was a PDF that I was working on that had a bunch of like chemical formulations for a particular something. And that actually did that where it would be a row of data. So it'd be like, X ingredient concentration, and underneath it would have any any additional information as like a note, and it would treat each row as like each entity as its own row, and it would just break it up. So when it came back down to formatting, I would then either, in this case, I was able to just ask the end user if they cared, and they didn't. They would just give it to me as a CSV, and they'll do whatever they want with it. But you might need to merge cells back together, or say, hey, if you see there's actually some really fun stuff you can do with smashing tables to the left to try and get all of them together if you really need to. But you may need to be treat the first row as data, second row as descriptors to the data, and then add it back in, and that would just be basic data frame management stuff. So when I'll pop this PDF open, and we can look at it, and I picked this particular document for the fact that it had an interesting table at the end. It actually has a lot of interesting stuff in general. But if you look at the end table here, right, it's a mutation table as well as a table of risk factors and the magnitude of association with those risk factors. And it's, a well-formatted, nice, neat little table. And when we look at the table that's extracted out of this, extracted using this, you can see that it, grabbed the table of mutation, the gene mutation, and mutation frequency, and it looks like a nice, easy to use table. I've had a lot of luck using Tabula to pull tables out for this reason, in that it's able to really read the table structure well and pop it back out, except for when you do have interesting tables, and I haven't really run into any good packages that handle tables well as a whole.
So what's Tabula doing? Is no OCR? Was it?
Yeah,
it's just all metadata.
It's just all It's just reading the byte string to look for table structure, and it just pulls out anything that it thinks is a table, which is why multi-columnar PDFs get real funky with Tabula here.
When you switch back to your PDF and you
Yeah, it's a good question.
Have it, like, I mean, I can see both advantages for treating that as a table,
Mm-hmm.
as well as like, I have problems with footers and headers, and like, information being in there, and then it constantly getting ported in,
yeah.
Yeah.
So that actually, in this particular example, became a problem when we OCR'd because it actually tries to read the edge line. But sorry, say that again.
The Tabula didn't recognize it.
Tabula ignored it. As you can see, it just ignored it and just read what it saw as structured as a table inside the PDF. And again, this is just pandas formatting to make it a little bit easier. So if we look at a multi-column PDF, and this is where I actually ended up having to learn the difference between why you treat multi-column differently from a single column, especially if you're looking for tables. If you just run Tabula's basic, hey, show me what all the tables are and read it, the way that multi-columnar PDFs are stitched together, it'll actually treat each column of text as a column of data. And it kind of dumps it back out in a horrific way, which is fine. I wish I had grabbed. Hang on.
Really?
Which is fine for tables because it still treats tables as tables. But if you have a multi-columnar PDF and you're trying to get the tables out and you're not careful and you just assume that it's going to function the way that it does with a single column text, you're going to end up with a lot of tables that aren't real tables.
So do you end up doing like two passes with different
Yeah.
tables?
And usually what I'll do is in this particular case where I'm saying, hey, just like go through and read all of the pages and treat them all as tables, right? I'll actually just tell it to be like, okay, I know that the first 10 tables that it sees will likely come out as junk text, and then the table that I need is actually table number 10. So I'll pass the index value 9 on my data frame to be like, hey, grab me just table 9, and it'll pull that out. The multi-columnar PDFs become really annoying, and it's like if you have to deal with scientific literature and you're dealing with reading data out of or text out of scientific literature, just make sure that you treat your multi-columnar PDFs differently than you treat your single column PDFs because they'll just be a little bit quirkier. And like I said, the reason that it's fine is even if it reads it out as a table like this, and all I'm trying to do is get like the text out in some sort of reasonably meaningful way, you can either just stitch this back together yourself by treating each column as a column and then trying to build your text back out of it, or you can just say, hey, let me go hunting for that particular table that I'm looking for.
It's a bit philosophical, but any thoughts on why the white paper scientific community seems to love multi-column?
It saves them space and print and things, so they can smoosh a lot of articles into. Nature is a business, folks. They like to put as much stuff in there as possible to get as much money as possible. And it was also for mailing, printing, just is easier this way. But you'll notice that in more recent times, if you pull a PDF from PubMed or any public repo, even things that are printed as multi-columnar in the journal itself will be printed as a single sheet, single column, because again, when it's digital, it doesn't matter, right? It's, that you can store it however you want. There's no real memory weight. There's no storage difference between a multi-column or a single column, especially when you're looking at the difference between maybe 10 pages and 12. But that adds up over time in a journal. And those journals used to get real big. So with PDF Plumber actually provides you with a little bit of extra functionality where you can actually tell it what your table settings are. So you can say, hey, vertical strategy is text, horizontal strategy. In this case, I passed them both as text because the single column and double column are both text. But the table settings for PDF Plumber is really deep. And you can, again, specifically tune PDF Plumber to the particular PDF that you're using to get the data out. And I didn't want to get into the deep nonsense of the settings, but if you're interested in reading about the settings and actually going in and looking at it, I highly recommend looking at PDF Plumber's help documentation because you can really, really play around with the table settings to get your text out. But if we run, this just failed. Oh, there we go. Okay. If we run PDF Plumber and treat it similarly to There we go. Yeah, treat it similarly. And in this case, I told it to go specifically looking for the data in the actual page of that single column PDF that contains the table that I want. You can see that it actually pulls it out. And to your question here, see author, manuscript, that the brackets on the side are actually picked up in this library, which you're right. It could be valuable, but it could also, in this case, that's just noise and junk.
And there's author at Langford.
Yeah, in this one, it took the last author and just was like, hey, here's author. But
It's better than
reasonably, though, you could just drop column 0. You just drop the first column, get your table out as you need it, and use it, and it would be fine. Like I said, both of these are pretty reasonable, usable, functional packages, and I've used them for different instances. I tend to lean towards Tabula because I like the way Tabula reads. Tabula also does I had a lot of trouble with PDF Plumber when a table stretched over 2 pages. With Tabula, you can actually play with some of their settings and actually get it to read around the page break and continue the table that it's extracting on the second side. That's another thing to keep in mind when you're extracting tables out of PDFs. Page breaks do matter. Sometimes you will lose your first row of data in the second table because it sometimes will misread it as a header and think that it already saw a header before and then just be like, hey, drop this row. But with Tabula, you can actually tell it to not do that. And you can do the same with PDF Plumber, but PDF Plumber is a little bit, it tends to read a little bit more of the data out in the sense that it picks up things like these author lines. I just find that Tabula has always been a little bit neater for what I need. However, if you can't set up a JRE in whatever thing that you're using, PDF Plumber will do the job, and it does a pretty reasonable job. And it comes down to, again, what is your use case and what environment do you actually have access to in order to actually do your job. All right. I think that just got duplicated. Yeah.
Maybe I missed it. What is the goal of your processing these documents? Is it just to transform it into text? Is it for search? Is it for AI?
It's whatever I need it to be. So I've had to do it for like transference to databases, so that static or PDFs out of tables had to come back out so that we could actually put them into data tables. Often, most of the work that I use the text extraction work for is to pull the data out to be either able to be passed to a string search or actually just store it out of PDF into like something like either a JSON or a text file so that something can pick it up and read it and not have to worry about formatting. So I've had to do it for a bunch of different use cases. It just depends on what I'm trying to get done in that day.
Transform to JSON or something if context doesn't matter.
Yeah.
And then otherwise you're going to have custom code based off of a category of
right. So
with certain types of tables.
What's really one of the projects that I was working on towards the end of being at the FDA was looking at EHRs that were stored as PDFs and trying to get like electronic health record data out, and that structure matters in that, and where the different sections are matters. So like just treating it all as a string is a problem. Can't do that. Well, you could if the structure remains the same, right? Like if you always know that between string A and string B is your patient summary, then you can realistically treat it as a string and then pop that out if needed, as long as that text is maintained. But what we were trying to do with that was a very, and this is where I learned that you could use the Adobe Acrobat OCR engine with just this essentially engaging its API to do the work for you. We had to get the text out of the PDFs and pushed into a docx because somebody wanted to then use it in the docx to then do something with it. So yeah, honestly, a lot of this work could be saved by just encouraging people to not do this, not store data in PDFs. But one can't fix legacy data, right? If it's stored that way, it's stored that way, and it's important to either bring it out and put it into a better, future-proof format. Or two, sometimes people just know how to print to PDF and email a document, and that's what they will choose to do forever, regardless of if you give them a better option. And so it comes down to dealing with your client, your customer, if that's all they're willing to do, you can only dictate so much so far.
Just on behalf of the average average user? Like, what, like, data format would be familiar to a non-techie who...
We've given somebody an HTML page and said, here are some fields and fill this field out. And they were like, no, I already have this document as this like PDF. And I'm just going to send it to you. Yeah.
Like every other document format is really uncomfortable for a average non-tech person to deal with. And so, and even ones that aren't, like we tried Mobi and EPUB, but like, then you have a variety in your like page numbers.
Right,
like,
right.
It totally looks different and can really screw things up. Like,
Yeah.
even if they're all are scientific PDFs, even though they're hard to, like, because they're smashing so much data and information in like a concise format or one that is like easy for our brains to process quickly. Like, and in obviously computer code is not easy for our brains to process quickly.
Yeah.
So like I think asking anyone who's not in tech to
Do something different. Yeah.
Yeah, some of them are surprising because even Word, like if you programmatically read in a Word document and you try and say, well, what page number is that on? There isn't one.
Yeah.
Because page numbers are not part of the document. They're part of whatever browser you're using, whether it's Excel or something else that reads it. It paginates on the fly. So I had one we spent weeks on and they're like, well, we've got to have page numbers. That's why we ended up putting in PDF, which
and again,
they're already in Word documents, but they had to have this page numbers.
And that's why at the opening I conceded the fact that PDF is great because once it's stitched as a PDF, regardless of what you open it with, as long as it can read a PDF, it'll read the PDF in the exact same format with the images where it needs to be, the pages where they need to be. You can do things like read section 2 on page 3, and it doesn't matter whether you use Javelin, Acrobat, something else, it'll always do that, or Edge for some people, right? That's absolutely fair, but I think what part of the work that Ricky and I have been doing at places like the FDA is trying to get people a little bit more comfortable with using something that is a little bit outside of their realm of what they already know, because then from a developer's perspective, it reduces the load on trying to sort of break stuff back out. And we've had some success. A current project that I'm working on for work is an individual that we work with loves using, even though everybody else is really familiar with using and likes to have everything stored as markdowns. This person will only use a WYSIWYG and they only want to use DocX. And so like I've spent the last few weeks trying to get like multi-imaged DocXs via Pandoc to be stitched out into Markdown, which then I learned that really Markdown doesn't enjoy having side-by-side images. So like,
I think in a lot of these cases though, you can also move it to make it a tool problem. Like coming back to your healthcare example with EHR data, which I can speak to this kind of healthcare in that universe. Like the tool, the EHR tool itself, like an Athena or an Epic or something like that, they can enforce the standards. So if they have the data in there, you can get some other protocol, whether that's HL7 or CCDA or some format that is machine parsable, and make it not like a user problem. Because to your point, it's like that's crazy to be like, no, change your whole life and your whole format about the way you expect to use things.
People would say like, oh, look at page 5 where a table is, and if
Could they put it in Jupyter notebooks? That'd be nice.
any markdown format, like just anything usable.
Every time the server doesn't
break.
sync, then you lose all everything.
Then they can use black to format.
So I think you weren't here. You hadn't come in yet. When
sorry.
No. This actually like it comes back around to what you were saying, right? In that people also just get accustomed to a flow, right? They're like, this is the tool I use to make. This is the tool I use to like send, right? And so they get really accustomed to thinking about things in those factors. And sometimes, and again, an example that I used is we had a problem that resulted in what could have been 15 years of work for one individual because somebody made a mistake and thought, well, I always get documents sent to me as PDFs, so I'm going to request these documents as PDFs, but they were actually CSVs that then got stitched to a PDF and then sent, which is really not helpful. Like they were already in a more friendly format. So just getting people to think about other means of transmitting data is really helpful and useful. But again, PDF is fine. I use it. I mean, there's a lot of things that I just put out into PDF and it's kind of helpful. I still, if I have to send like a document to somebody, will send it as a PDF because then I know they're looking at the exact same page I'm looking at. But I also store it in a format where I can then, make edits later. Yeah.
Quick question. Have you reached out to Adobe? With this idea?
What idea?
The idea of what you're doing. So basically, I just 3 days ago filled like 20 pages of PDF because that's what the federal government wants.
Yeah.
So we're talking 2024, right? So all the other documents for, let's say, selection of the benefits that I did for the company were already on HTML. So the data is very easy to be extracted and put in some kind of other database and do statistics. So I said you have a potential product to develop here, because at least for the federal government, if they want to, any agency, extract and get into more detailed statistics and data, they are continuously doing the PDF. Even, I will go beyond, I would say even every single form. The computer that I receive, they say to me, you need to sign that document in PDF and send it to me. And it's like, so how are you planning me to do that if I don't?
Yes, signature certificates and things can really also break your readable PDFs and stuff too. So it's kind of
the one thing to realize though is PDFs were never intent. There was never any attempt to make them editable.
Yeah, I mean that a flattened PDF is meant to be unchangeable.
Well, it's meant to be like whether it's no matter where you're printing it, it should look exactly the same, and that's what its real intent was. So it was never designed to be something you could edit. I think at some point early on they tried to come up with their own editable format. And Microsoft and a few others basically said, no, we're not going to let you.
Yeah, I think, what was it? It's like PDF-C? PDF, there's like it's PDF and then a letter.
Very long.
Yeah. I think
If it were solvable, this problem, someone would have solved it because the dollar value is so insanely high.
Yeah.
Azure's tried. Azure has doc intelligence.
Yeah.
All the hyperscalers have tried. Nobody's cracked it.
Well, and Adobe, like I said, has snuck tools into Adobe Acrobat Pro that allow you to essentially pop those PDFs out into readable formats, right? Like even some of the lower end PDF readers will do print to Word and it'll do a pretty good job. And again, Adobe has an OCR engine baked into Acrobat Pro that you can just fire off in a batch job to just read PDFs. And it does a great job. Well, it does a pretty good job.
I don't think it's an intractable problem. Maybe that's just my optimism, but I think there's just like thinking outside the box a little bit. It might be.
So again,
vision language models are the pretty obvious solution here, like cold poly.
Yeah.
If you have a question about a PDF using multimodal embeddings, you can just ask,
and
get a region in a PDF. And then you have a reference to it.
And that's, I mean, and again, I think we've built technology solutions to get around what was a legacy issue that may work downstream, but there are still tons of repos that have to be parsed, and sometimes people don't want you to be using a Gen AI model or an LLM model or a machine learning model on your data, and so you have to figure out a way to get that stuff back out. And
so no Tesseract then?
No, actually I got in trouble for using Tesseract at one point, but then I stopped telling them that I was using Tesseract, and then they were happy with the results, so they didn't ask. I think it was just
black box.
I'll tell you about it later. It's a very funny story.
So they do not want you using AI to read their PDFs or to try to make sense of them? Is that what you're saying?
Who's the they in this case?
Well, whoever, when you said you got in trouble for using Tesseract.
At the time, this was like a few years ago, I got in trouble because I had to explain to them that it was like a machine learning model. It was a machine vision model that was like running a C engine, and then they were like, I had to go through the process of getting its security approved effectively to be usable.
And you don't understand how it works.
Yeah, and so like the timeline that I was working on, the process to get it approved would have been a little bit longer. But luckily I found somebody that could help me that had a better understanding that was like, this is the route you want to take. So I was able to use it. But then I went
Well, a lot of places are having problems too, like, there's a lot of stuff AI can do this.
Yeah.
The problem is that a lot of them are sending your data
Right.
somewhere. And
Okay.
it's the,
I was gonna
where
say
is it
this-
going and what are they gonna do with it?
And-
This
Are they
seems
gonna,
ideal for AI, just read this, give me the table in
Yeah.
CSV format, and boom.
It does a pretty good job.
Unstructured, have you tried unstructured for this? They have an open source version. It runs a layout model first.
Okay.
Like the small one is the YOLO model.
Okay.
And so it puts bounding boxes around each region of the document and then decides based on the classification of that region, should I OCR it? Should I
Sweet.
tabula it? Right?
Yeah, yeah. That's
So-
really nice. That's really
Yeah.
useful.
And it works pretty well. Tesseract for like lots of documents, it's really annoying that Tesseract doesn't run on GPU.
Yeah, right.
So
It's a
you
CPU
can't-
only run too.
Yeah.
That's very
Really? Yeah.
Yeah.
Well, at one point they wanted to depreciate Tesseract. So do you know if they actually depreciated?
I mean, it's still
It's out there.
it's
I
still
mean,
out
it's
there.
It's
Yeah.
out there, but is it updated? Because I think that's part of the reason why Google transitioned into making it a
Right. Google wants you to use their API-based like
Yeah.
service now,
so like
which
that-
is using a lot of this data to do.
Tesseract is open.
Tesseract is free, open. You can
Yeah.
install and run. Yeah.
It's like,
Yeah. So and again, the advantage of something like, and this is where we're getting at, right? The notion of like having to send your data out to a model like via API somewhere to then have it come back. That idea of your data leaving and coming back scares people, even though it's like it's encoded and decoded at the client side, right? Like, but people still freak out a little bit about it going out and back, and that there's no real, can't really do anything with it. And that was something that,
another part is what are they gonna do with it? So,
yeah,
I mean, a lot of the reason like ChatGPT works for like when you're coding
yeah,
is because they
'Cause they
basically, well, they
scraped
basically
in,
took-
yeah,
They scraped a bunch of other people's code.
yeah.
Most of it
And actually,
not according to the usage agreements, but
yeah. Well, I mean, so I actually, for this thing, before Perplexity got in trouble, I made a fun little document about Ricky to just demonstrate how, like, a flow would work for like a document with multiple types in it. And again, that example is in this repo, and you guys can have it. But I used Perplexity, and then it was like literally I used Perplexity to do it because I got a free subscription to Perplexity because I bought a Rabbit R1 because I thought it was funny. It's very funny. It's terrible. It's really entertaining for a 10-year-old though. My niece spent like hours with it, just walking around asking it to tell terrible stories about me, in which I was always the villain as I was buying her candy and stuff, and I was like, "You're a jerk." That's on recording. That's great. But I was using Perplexity because I was like, hey, I have access to their pro model. And then, yeah, that was the big thing a couple months after. I think in April, Perplexity got in trouble for their ignoring of the robots.txt. Like they were, and I think Wired cracked the article about it being like, look, they set up a sting operation for the Perplexity bot and found that it was actually ignoring the rules and just picking stuff up in places it shouldn't be. So like, yeah, I mean, it's what are they going to do with your data when they have it? But these models, and again, the example with Olama is running locally on a CPU on this thing, and it's pretty all right. It's slow, and you don't want it to do anything interesting, but being able to extract your own text and then passing it to an LLM in a closed box, in an internet disconnected closed box, is appealing to a lot of people because then it's, I have my mortgage documents, I have an LLM at home pointed at my mortgage documents, which I don't necessarily want out in the universe, right? Because I don't know where things are and I don't understand how to read those documents. It's okay.
Are there any open source multimodal models?
Yes.
Yeah, because the Llama, yeah,
Not a bunch. It's less common.
but yeah,
Because
Lava. I think Lava is available.
Lava's the best one on leaderboard right
Yeah.
now. Polygemma is
Yeah.
smaller, so that's better for most cases, right?
Polygemma?
Polygemma, so it's a Gemma.
It's Gemma.
A Google Gemma model. So Gemma has its own weird license, but
Yeah.
Lava is like open.
This laptop isn't connected to the internet, but for those of you that are, I actually use Ollama a lot to bring in different models because they're very good at, like, as if there's a new open source model that's available, they'll just publish a quantized version of it for you to bring down and use. So if you go to, just Google OLLAMA, and you'll see I think right now it's a repo of about like 34 different AI models, and they can all be brought down and run. And if you have a CUDA-enabled GPU, it picks up the GPU side. If you don't, it runs natively on CPU. It's slow, but it'll work. And the example that I use downstream is actually calling Ollama on this laptop and just sort of like asking it questions against a document. Okay, yeah. So Tesseract. Again, we talked a lot about this. With Tesseract, the one thing you do have to do is pop the image out, and Tesseract likes things as an image format. In this case, I created just a PNG out of that single column document. This is the page 28, which is this image, right? It's just a figure, and you'll see something interesting happen with the author manuscript on the side. But when you actually read using Tesseract, again, it kind of doesn't do a great job of handling like rotated text, which I've had to actually resolve in the past, where it's a really janky way to do it. So if anyone has a better way, I'm happy to hear it, because I would love to make that work a little bit better. But what I actually ended up having to do is actually target a region of text that I knew was rotated, have it read that rotated text, and then if it didn't identify a common character, rotate it 90 degrees. If it didn't identify a common character, rotate it 90 degrees. And usually within 3 rotations, I'd find it as the image was rotated. Once it found a common character, then I'd just be like, all right, OCR across, and then rotate it back, OCR across. I considered doing OCR, rotate, OCR, and that was just, at least for what I was trying to do, it was just not fun. It just took time, and not something that I wanted to pursue. But Tesseract is really powerful, and Tesseract will pick up even noisy text pretty well. The example that I was talking about like legacy documents, some of them were actually like camera images of documents that then were stored. So they were like really grainy and noisy. And I was able to pass Tesseract's like Telugu, which is a South Indian language, like model across those things and actually pull stuff out pretty efficiently. Like it was better than what the previous state was, which was nothing. Like we couldn't use it for anything. And so it was really good. And luckily these things were typed in that script. It still does not do a great job with handwriting, though I have noticed that it's better at handwriting of languages where the characters are a little bit more distinct and rounded for whatever reason. So Thai, Telugu, anything that uses like sort of a rounded, almost Sanskrit-like script, for some reason they just work a little bit better. And as you can see, it's a pretty straightforward, easy flow. It's grab the page, pop the image out, pass the image over, and we're using CV2 and fits in order to sort of break it out and run this. And all of this is to get to an end state where you can get that text out and use it for whatever that purpose might be for your particular use case, whatever that is. Oh, there was something else I was going to say.
CV2, is that just like an image reader, like Pillow or something?
Yeah, CV2 is actually, I think, it's an image reader, and I can't remember what CV stands for.
Computer vision.
Computer vision, thank you.
Okay.
Yeah. And so you can use CV2. Before I started using CV2, I was using a combination of Poplar and Pillow to do the same thing, pop out and then pillow it out. So. And again, your end state is to get that out as an image, whatever that image is, and then you can pass Tesseract over it. I'm actually also just using the base Tesseract model for this example. There are high fidelity models for Tesseract that are also available for free, and they are a lot better, but again, take more time and are bigger in terms of just size. They're just larger because there's just more there. So putting it all together, we get back to this flow, right? First, I always check for machine readability. Does it contain tables? Does it contain images? And then I will, pull these things together as I need in order to go. The larger function is essentially this PDF to text, and it just goes through and takes each of the different examples that we used here and spits it out. You can read in a document here, and the document that I was reading, hang on, right, cleared everything. So see, it's converting, reads page 0, reads page 1, says, hey, I need to send that that page to the OCR pipeline, OCRs it out, and then reads page 2, stitches it all together, and here's a little story about Mike Dubbin, the young Viking warrior. I'm not gonna, and actually I actually put this example together because of a use that I actually ran into, which is the, again, generated using Perplexity AI. So, probably stole from a lot of people, like all of them, I guess. But the middle page in this is actually a giant image of a ginger-bearded Viking. I'm assuming this one doesn't have hair either. But there was actually a really interesting problem that I ran into once where I had a pipeline put together to read data out of PDFs, and I was getting most of the data out, but the functional bit that I needed out just wasn't retrieving out of like about 10,000 documents. And so I went back and looked, and the person that had created that PDF had done something really interesting in that they had taken images of tables and put those table images in the middle of a text block. And so before that had happened, I'd run into a different scenario where I needed to check for what the health of a document looked like and whether or not I was getting about 80% out. And that table, which contained all my data, was about 15% of the net whatever was in that document. So it kept passing my check of 80%, being like, you're good, you're good, you're good. And then I had to go back. And that's sort of why I built this middle level of, is there an image in here? And actually what I started doing by the end is, regardless of whether or not I went looking for a particular image page, I would just pop out all images using Poplar and just OCR them all, because it became just easier and more efficient for my unique use case. And the encoding Latin 1 because of the weird byte character. And this is running Olama locally on this machine. I'm not going to run it because it's running on CPU. It takes a little bit of time, but this is a conceivable end use case for a lot of individuals, in that you have text that you don't want to pass out, you want to parse it out yourself, and you want to run it on a local model. And this is lightweight and small enough that this entire flow can just sit on a small Linux instance in AWS or wherever. You can put your documents there, pick them up, read them, and then dump out summaries or categorization or tagging or topic modeling or whatever you want to do. And so, yeah, that's top to bottom how this flow works. Again, the big take home is determine what your use case is, whether or not, what the format of the data is that you're trying to get out, and then pick appropriate tools. There's so many of these tools out there. These are just the ones that I like to use, and they work really well for me. And the end game of all of this is to be able to get data out in a machine readable format so that you can pass it to something like an LLM, or you can pass it to a topic modeler, or you can pass it to some sort of database to store, doing it locally yourself. And once you have your flow built, and you just have some parameters that you can tweak depending on different edge cases that you might see, it becomes really efficient. And again, one of the examples that I used is in about 3 months of both coding and running work, we saved 15 years of time if somebody did it manually. And there's just so much stuff out there that's like that, and now that never has to be done again, right? It's stored so that nobody ever has to do that again, because these are data sets that people keep going back to. All right, cool. That's all I had for you guys. hope I didn't bore you guys to death. And thanks for having me up here to talk about something that ate up a fair amount of my life for a little while.
Cool. Thank you.
We'll have access to these Jupyter.
Yeah. Devin over there will get them over to you guys with all of it.
Do you have any questions that we want to ask?
Has anyone had experience with Abby Finder OCR?
Yes, I actually had to use that a lot until I decided I just wanted to use Tesseract myself. Abby's good. So Abby's problem is, at least for us, was that they changed their server licensing model. Right. Initially, you could buy, before Abby 14, you could buy an unlimited server license where you could pass an unlimited number of pages. And then from, I think, like Abby 15 forward, it was a set number of pages per month. And then that number kept decreasing while the price kept going up. But Abby is really good and does tie into like most of these workflows, and it does an incredible job.
Yeah, I trusted the art for.
Yeah.
But I haven't had much experience.
It's really nice, but from, again, most use cases, if you have access to Adobe Acrobat Pro, either personally or like from work, just hit the Adobe API and just do it there, and it's real fast, and it'll do all sorts of stuff. It'll do, PDF to CSV XL, do PDF to Word, it'll do anything you want. You just have to, write it out.
My only resistance is all the tendrils that it always sticks all over my computer of like
Yeah.
Adobe products that are updating and
Yeah.
Yeah.
And they're also really big applications because they're choking engines into them, right? But so that's good. And again, I can't recommend Tesseract enough. I love it. I use it a lot. I always end up having a need for it for some reason, whether it's as for fun or for actual like work.
You mentioned you had to have a JRE, right? But I noticed you had high Tesseract. So is that when you're going the Python route, you don't need a JRE, then, right?
So PyTesseract is just the Python package that's just calling the Tesseract engine. So that's it's a baked C exe. So
you're not going to set up it.
No,
Okay.
no. So actually, and I think it's in here.
It gives you some Python code that wraps around all the command line
Yeah.
arguments that you had.
I mean, it's
directly with Tesseract.
Python's just an API to C. That's all you're doing here to that engine. So yeah, you're just calling that in after it's been installed. And like I said, you can bring in, for those of you that are interested in using it, really consider checking out some of the some of the higher fidelity data sets for Tesseract, because they do make a huge difference if you're looking at really noisy images or weird languages, like weird language characters.
What would you get as
A cell phone image of like an old document, or a camera image of an old document. It wasn't even a cell phone image. Actually, it might have even been like a film image that was then scanned. There was just so much just like gray noise over all of the characters, and it just was like, I tried playing around with trying to just clean up the image, and then trying the high fidelity, the high fidelity Tesseract model picked up most of what I needed. Yeah, which I'm sure, I mean, you guys might have instances of that. Like, I don't know if you guys have weird data that's stored. Yeah.
So obviously anything like this requires a lot of manual intervention to like review what's going on and make adjustments accordingly. Did you find any tools or methods to evaluate the quality of the document being extracted? So like when the two columns were running together, something that would understand language would know enough to say this has a low score of making sense, and then you'd be able to then, target those document types?
So I didn't do any of that, but that's actually, it's really useful. That would be really good, right?
So you're not testing?
Well, I didn't. So my testing was that I literally would like run it and be like, "Hey, this thing like exploded," and then I would look at my document types, and then I would categorize it, into pools, and I would know what those pools were. But like having something that auto tested for you would be great. And then with the with the LLM model that he was referencing, where it can actually go through and just do a regionality check and do that, this would reduce a lot of this kind of work. But yeah. I didn't need to. I mean, because it's like I would get a repo of 30,000 items that looked one way, 30,000 items that looked another way, and then in the second repo that I would receive would have those two patterns. So I would do a pattern check and be like, does it look like pattern A or pattern B, and then run that particular like flow. But it wasn't like I had something going out and surveying the documents to determine which one goes in bucket A and which one goes in bucket B, beyond being like, did this work? No, go over here.
There are some NLP-based methods too, besides neural networks, like looking at the sentence tokenization and seeing if things have gotten like seriously jumbled in the text.
Yeah.
Like,
But that
Does it
still,
actually look like a valid sentence or not?
well, yeah, I mean, the tokenizer is a small model, but it's
Right.
still a model.
right, but most of these tokenizers look for like sentence ends, right? They look for
Well, there are lots of types
yeah,
of tokenization.
yeah.
But it's
So-
a cheap model compared
to a better,
that it's
yeah.
a probabilistic model of the tokens
Right.
in the language, right? So it will
Yeah.
provide a better. You don't need to go all the way to an LLM, which would be super expensive. Nobody's sending all the tokens from all their PDFs to an LLM.
Actually, and in this case, right, you could take a couple of the tokens that are generated in the. So up here, I do generate some tokens, right? Just using NLTK to do it fast, but you could say, pass a random selection of 50 tokens to the LLM and say, do these look like real sentences? And if it says no, then you might be able to.
Sorry.
No, go ahead.
You could basically do a small embedding model and
Yeah.
make your own classifier. Really simple. Don't even.
Yeah.
Probably a decision tree would work with embeddings, and that would run fast enough compared to a neural network, especially for something small. If you already have the embeddings.
Yeah. I mean, I was doing, again, a small decision, right? Is it A or B or C or D? By the end, I think I had 16 patterns that I knew were consistently popping up, and I knew how to find those 16 patterns quickly. So then I didn't waste time trying to run one after the other. I would just route it to the right pattern and just run.
But Spacey or NLTK probably has some off-the-shelf examples of figuring out how jumbled a particular text is that would help to figure out.
One
things
thing,
in the shelf.
even the simplest form, I don't know how they work, but a grammar checker,
Mhm.
you're in Word or whatever,
Yeah.
and granted, a scientific journal may not be the same, but something that would give it a grade, this is the reading level of a, kindergartner, or this is
Yeah.
garbage, or something like that, and
I-
then maybe, you know where they should fall, and then if they deviate a lot, then it's a candidate for being problematic.
And I don't know how Word does the readability score, but there's probably some little bit of that in there because it looks for grammatical edits and looks for spell correction, but then it gives you that readability score. It'd be fun to build your own something like that to be how readable is this?
Blue and Rouge, NLTK has those. Those are
Okay,
yeah.
that's cool.
They're
Yeah.
very fast, right?
Spacey is very trivial to figures out sentence structure.
If you can figure out how to use the Spacey API, I hate it. So. Okay.
SPACY
It's a natural language processing tool.
library.
I'm sure it's good if you know how to use it.
Yeah.
I don't know how to use it.
It's like NLTK. It's like the toolkit, but a little bit different.
Yeah, it's a little bit deeper. There's a guy that we work with who actually has a PhD in semantic web, and that dude does some weird stuff. You don't know him. His name is Rashid. He's cool. He's a cool dude. I'll introduce you one day. Yeah. So whenever I used to get stuck on stuff, I'd be like, how do I do this better? And he'd be like, do you want it better, or do you want it faster, or do you want it done? And it was I had to make a choice between which of these three buckets I needed. Sometimes faster and done were the right bucket, sometimes faster and better were the right bucket, but oftentimes the bucket always had done in the in the need. So yeah, go have fun, figure this out, and maybe there's $1 million product in it that you can pitch to Adobe. But I think that they're just going to be here's our OCR engine, go buy it.
Yeah, I think that's probably the answer. That
Yeah.
it's something that you have to pay for that you already have it. I'm curious. 15 years worth of someone manually going through all this. So what the final product look like? So everything is in a repository or 3 different buckets. But if you want to get a scenario of, what is it that you're going to ask? Are you going to create a chat box to ask questions about
About that?
DNA.
About
or-
that document
Yeah.
set, what was the end purpose, or?
You know, how would you get to that? You need AI to.
Oh, okay, yeah,
How does the regular user get to
Yeah.
15 years worth of data?
yeah,
You know, right now,
That's how people are doing it, right? You take like the RAG thing that we're talking about, you take it all, you put it in you do a semantic search, a super semantic search, and then you can get your answer, right?
you get you get some response back that may or may not make sense based off of what it was querying. For that example, what was really fun is again, accounting for how much time and what the actual cost would have been to do this if somebody did it manually. Like, I was able to give a number, but I essentially, at the end of that, I and the other person, the two of us that were working on this, we were able to then be like, okay, this is how much time it took, or you can make this one change at the ingest point that would reduce all that work. And it took, a couple iterations of people arguing over whether or not they could make that change. But once they made that change, that entire pipeline that we wrote, irrelevant, because we were fixing a problem that didn't need to be fixed if it wasn't accidentally broken to begin with. So and this gets to this question of modernization of data as a whole, right? We have a lot of examples where people will do something like this. Oops, sorry, you're behind me. Will do something like this, but then won't think about storage in a way that is useful for archiving or for legacy usage. They don't think about that. So encouraging people to think about better file formats, or encouraging people to create or store their data in better ways, solves a lot of these weird problems, because getting to this whole AI ML future that we're all hurtling towards, data is king. So having access to being able to crack your data out is really valuable.
And it's like we need a newer version of PDF where formatted data is stored in a formatted way.
Yeah, so
Well, there's ODF, open document format, right?
Yeah.
The PDF is like our fax machine.
Right.
I feel like it's better than a fax machine, but that's where the gap is filling.
And I think
Definitely.
metadata injection into PDFs has got better after Acrobat 5 or something. There was a point where they started being able to, they were encouraging people to fill out metadata fields and smush and it was starting to store XML in the back end of these PDFs, and so you got better stuff. But it was still one, your end user needed to go and fill out those fields or have a means for those fields to be filled out, and then people just were like, oh no, I don't want to do that. Sure, I have all these options, but I'm not going to do anything with it. But I think the nice thing about the way that we're moving towards the future is people are getting a little bit more comfortable with technology, because they're kind of it's unavoidable.
I feel like it should really be on government to help improve education across the board. It's kind of we're at the level of not being literate, but just on tech.
Yeah. And so some of the stuff that Ricky and